Right, the first question we have here is a 5-gram bullet is fired horizontally at a 10 kg cube of a soft metal which is at rest and stick in it. The cube is free to move and has a speed of 0.5 meter per second after impact. We are asked to find the initial velocity of the bullet. All right, it's very, very important that we understand the subject matter. That's what the question is trying to tell us to find. Okay, so we are having two mass. We have the bullets and then we have the cube. All right, so let me say mass of the bullet is 5 gram, and there is a problem here. If we're having gram here, then it means that we need to convert this to kilogram, and converting gram to kilogram is dividing by 1000. So dividing this by 1000, so it's going to be 1 2 3. The decimal point will be here, so it's now becomes 0.005 kg. Okay, that is settled already. And now let's consider the next mass. The next mass in the question is actually 10 gram, and that is for the cube. So I'm going to title it MC. Now, since we have differentiated our masses with the first letter, we are going to also make sure that we identify the velocity for each of these mass. And that will be before collision. Everything I'm writing here will be before collision. So I'm going to write UB, that is the mass, the initial velocity of the bullet before collision. 5 kg is fired horizontally. I think that's what we're looking for. Yeah, we're looking for this. Okay, so what is UC? That said that at 10 kilogram cube of which is at rest, so it means that UC is equal to 0 meter per second. Okay, so there's also very important information. Let's say the cube is free to move and have a speed of 0.5 meter that they stick together. So it means that the final velocity, let me just type it here. Final velocity of both the bullets and the cube sticking together equals to 0.5 meter per second. So just to chip in this for more information, this is just trying to tell us that this is actually an inelastic collision, since the two mass stick together and they share the same velocity. All right, so momentum of the system before impact equal momentum of the system after impact. So that's what we'll be using. Momentum of system before impact equal momentum of system after impact. We know momentum is actually mass times velocity, so I'm going to write the formula. The mass of the bullet with the initial velocity plus the mass of the cube with its initial velocity equal, since it is an inelastic collision, it's now become MB plus MC times VBC. That is sharing the same velocity after collision. So I'm going to substitute the value. This now becomes 0.005 times UB, that's what we're looking for, and then this 10 times 0 equals 0.005 plus 10 times 0.5 meter per second. Okay, so this is actually going to go away, so we are having 0.005 UB equal 0.005 plus 10, that gives us 10.005 multiplied by 0.5. So if we multiply these by 0.5, it should give us 5.0025. And we're looking for UB. UB now equal 5.0025 divided by 0.005, and this will give us 1000.5 meter per second, right? Or I can convert this 1000.5 meter per second to actually approximately 1 kilogram. So sorry that's 1 kilometer per second. All right, so this is actually the solution to the question, and then it's actually positive. It's actually at the positive x direction. That if I really, this actually is speed. If I want to put it in its velocity, then it's very important that I state the. Am I still writing kilogram? I'm sorry, it's kilometer per second. Okay, so it's at the positive x direction. Positive x direction. Someone might be asking me how do I know it's at the positive x direction? It's because the answer is positive. Okay, so this is the solution to question 1. Let's dive into question 2.